Okay, so we're going to draw a chart. Remember, these are rational expressions or rational equations. And we have John. Can I what? Good, John. And I have Deshaun. And we're going to have the rates and the time. Okay. So we're going to multiply these two together. And that's going to equal the job. Okay, so John can paint a fence in 6 hours. So that's his rate, correct? He can paint one fence in 6 hours. Deshaun can paint the same fence in 7 hours. So he can paint his one fence in 7 hours. How long would it take them if they worked together? So we're looking for the time. We don't know what the time is. I like putting it over 1 because we're dealing with fractions. So this is total. So I have 1/6 times x over 1 gives me x over 6. 1/7 times x over 1 gives me x over 7. And if they work together, so I'm going to add them, that's going to equal the job, right? Here, let me just go out. So that's exactly what I'm going to do. X over 7 plus x over 6, that's going to equal my job. Remember how to do this? Find the LCM, get rid of the fractions. My LCM is going to be 7 times 6. It's not even the LCM, just common multiple of work. 42. So I'm going to take 42, multiply it to each term. Gentlemen, knock it off. Maybe you should learn something for a change. Okay, now, you can do this one of two ways. Now, this is a pretty simple problem. I suggest that this is 42 over 1 because we're dealing with fractions. You could do it this way. I suggest that you do it. You're going to multiply 42 over 1 times x over 7 plus 42 over 1 times x over 6 equals 42 over 1 times 1, or 1 over 1. Well, kind of, you cancel out and then multiply. Okay, so 7 goes into 42 6 times. 6 times x is just 6x. Plus 6 goes into 42 is 7. 7 times x is 7x. And 42 times 1 is just 42. Now, if you're really good with fractions, you know what we did. We just took this x, multiplied it by this denominator, got 6x. We took this 7, multiplied it by this numerator, got 7x. And then 42 times that. I tell students that shortcut, but when we get to little harder problems, they kind of forget and make mistakes. So it's up to you how you want to do it. All right, 6x plus 7x, 13x equals 42. Divide both sides by 13, and x equals 4. So they could do the job together in 4 hours. Not that hard, right? They have a bunch of these on the quiz and on the final. They just keep coming up over and over and over again. See, I only have one senior that's right. It's gonna pass my course. I'm not sure. Oh, 6x plus 7x. Combined like terms. Bless you. Bless you. You're welcome. All right, you ready? I'm going to make me a chart. Okay, working alone, Perry can pick 40 bushels of apples in 9 hours. So 40 bushels of apples, that's my rate, time, total. 40 bushels in 9 hours. One day his friend Michaela helped him. And it only took 3.94 hours. Okay. All right, so they took together. This one we're going to have to figure out here because we're going to have to change something. They both took 3.94 hours, right? So that's the total time together. This 40 bushels, that's the one job. You with me? That job is 40 bushels. So what I'm going to do is change this 40 to a 1. So I have one night. That's one job, 40 bushels. So one job for Michaela. Do we know how long Michaela took? It doesn't say. That's what we're supposed to find out, right? What would it take Michaela to do it alone? So that's what we're trying to find. That's my X. You could, it's the one job of 40 bushels. Now you could use 40, but it's just going to be big numbers. Okay? I just take it as one job. 40 bushels is one job. Okay? So, we're going to multiply these across. Remember, this is over 1. This is over 1. It's a whole number. So I have equals 3.94 over 9. And then this is going to be 3.94 over x. You with me? You with me? You with me? Everybody? Except for these nimrods that are going to fail because they play video games every day. You guys are actually listening and taking notes today. I'm impressed. Okay, so I'm going to add these together, set it equal to 1. 3.94 over 9 plus 3.94 over x. That's going to equal 1. What's my least common multiple? 9x, right? Okay, so again, what we're doing here, this 9's are going to cancel, so 3.94 times x, I get 3.94x. Here, the x's are going to cancel, so I'm going to have to take 3.94 times 9, and I'm going to need a calculator. Okay, 3.94 times 9, I get 35.46 Now, be careful here. What's a big mistake that usually happens here? People don't. They bless you. People will just put the 1 there. Don't forget to multiply the 9x times the 1. 9x. Okay, solve for x. Let's see. I'm going to subtract 3.94x from both sides. These cancel. I get my 35.46. 9 minus 3.94. I get 5.06x. You with me? Huh? I want to get x by itself, so I'm going to divide both sides by the coefficient 5.06. So, 35.46, 5.06, and I get about 6.3 hours. Now, does that make sense? Yeah. I mean, if I get a number like 1,000, I know I did something wrong. Are we good? Yeah. Let's do one more.
So you're doing 3 and we're doing 3 then?
You think? I want to make sure I get a different one here.
Do 36, please. You've got like percents and shit in it.
No, don't do a percentage one. It's not. We're not going to get into that.
Well, then you're just going to leave us with 2 if you do.
Yeah, maybe I'll just say that's it. Yeah, I'm only going to leave you with 1.
Well, if you do another one.
I thought I had another worksheet.
Just don't do another one, man. Let's do the last 2.
You know what? I'll leave you that 1. I'll make up another worksheet for you tomorrow. And we could do a little bit on the probability worksheet. How about that? I wouldn't do this one either. Try doing number 33, and I'll make up another worksheet for you guys tomorrow. And let's do a little work on the probability. Okay. I grabbed the wrong one.
Why don't you just move your desk back?
That thing broke.
No. The one you had like 2 years ago.
Oh, it's in my basement. I actually fixed that one. Same thing. The cylinder was broke. I put a new cylinder on it. Okay. Let me get the answer key so I can make sure I teach you guys this right again.
So I didn't mean to do it. She's going to keep letting it run.
Huh? Oh, should we make another? Okay, so this is more 11.2. What is the probability of choosing a girl from the students in our class? Yeah, we don't know how many girls. I'm not going to do this one. Deck of cards. What's the probability of pulling a red? Well, there's 52 cards in the deck, right? How many of them are red? One half. Half of them are red, right? Yeah. 26 out of 52. If you want to reduce, that'd be one half. I'll take either one. In fact, this is... all of these are a deck of cards, right? So all of our denominators are going to be what? 52. Okay, now, what's the probability of pulling a heart? 13. And that is 1/4. Because 13 goes into 52 4 times. Oh, you mean how many, how do I know cards? Well, think about it. There's 52 cards in the deck. Half have to be red, so it's 26. Half of those are diamonds and half are hearts. Oh. Oh. We'll have to teach you some card games. Okay, so the probability of pulling in red 7. 2. Good. So that'd be 1/26. How about a black heart? 0. Sorry. Actually, I don't care. Okay, rolling a dice. So what's going to be our denominator? 6, right? Probability of rolling a 4. 1 out of 6. Even. Let's say I've got 2, 4, 6, 3 out of 6, which is 1/2. Probability of greater than 1. Boy, these are really easy. Well, this one's hard. Bill, John, Sue, and Bob are all up for promotion. Their boss is going to choose a team of 2 people to lead their department. Everyone is equally likely to get the position. Show the possible combinations for the team. Well, let's see. There's Bill and John. We have Bill and Sue. We have Bill and Bob. Then we have John Sue. John Sue. John Sue. John Sue. Then we have John Bob. Good night, John Bob. Good night, Bill Sue. And we have we're missing one, aren't we? Sue Bob. Sue Bob. We got them all? Okay. So what's the probability of Bill and Sue get the promotion? Bill and Sue. Yeah, just the 1 out of 6. Probability Bob is one of the people. Bob, here's Bob, here's Bob, here's Bob. So 3 out of 6. Boy, this is easier than I thought. Team is made up of 2 men. By the way, this is pretty misogynist.
But Sue could be a guy's name.
Sue can be a guy's name, right?
But it can be a guy's name.
Yeah.
Like a wash one.
Did you have a question?
Johnny Cash, I beg to differ.
Let's see. Bill John, Bill Bob, John Bob. That's it, right? 3. It's 1/2. Good night, Bill Sue. Good night, John Bob. Good night, John Sue. Good night, Bill John. Let's see.
Why don't we just do this on our own?
Yeah, why don't you just do these on your own? I wouldn't do these. We didn't do those.
How far down did you go?
God, I keep doing them for you. You could do number 6,
What all did you cross out on this page?
page 3.
The whole page?
Yeah. Which means we're not going to do page 4. Page 3. In fact,
Do page 2.
no, there's more. No, you could probably do these. I wouldn't do anything with percentages. I wouldn't do. Yeah, anything with percentages, I wouldn't do. No. You guys want to review some conditional probability? Okay, remember, given is our new denominator, right? Okay, so I'll do these two. The probability. Here's my totals, right? Total number of what is this? Trees, workers, people. The probability of independent. Well, let's see. 17 are independent out of 140. That might reduce, but I don't care. The probability executive. Now, given Republican, there's our new denominator. Shh. Whenever you see the word given, that's a new denominator. So, Republican, 55. That's our new denominator. Executive. Executive, we have 48. Let's be careful because, let's see, we counted 48 twice, didn't we? Executive and Republican, so we have to minus 34. What? Are you with me? Because Republican got but it is in the denominator. Maybe we won't have to. Yeah, we don't have to because it's in the denominator. All right, put that in a calculator. I don't care. You can leave it 48.55.